Hello, my name is Zain Bankwala. I'm a third year psychology major. I was born on a Monday, and my favorite Netflix original is Arrested Development.
Hi, my name is Miranda Papano-Cannell. I'm a third year psychology major. My favorite Netflix original is Umbrella Academy, and I was born on a Tuesday during a meteor shower.
Hi, my name is Issa. I'm a second year psychology major. I was born on a Saturday, and my favorite Netflix original is Sex Education.
Hi, my name is Riley Quinter. I'm a second year psychology major. I was born on a Friday, and my favorite Netflix original is Stranger Things. For this project, our group analyzed data relating to Netflix original TV shows.
So, our data was collected in 2019, and we collected all the Netflix TV originals up till that point. We found the data on GitHub, and it has about 358 observations, and they have like information like the show's release date, the genre, language, and a bunch of other relevant information. So we chose this data set as a group because we all enjoy Netflix, and we were curious to see the distribution of certain variables throughout Netflix's productions.
Okay, so here's a list of all of our categorical and numerical variables. First, under the categorical variables is the title, which is pretty self-explanatory. It shows us each show that data has been collected from. Again, there are 358 titles in this data set. Next is Netflix label, which is Netflix's categorization method. So it's a little bit different from genre. Shows receive more niche descriptors like crime drama, sitcom, anthology, and others that are then presented to audiences by their watch history and interest. Premiere shows the date at which the series first aired. Status shows whether or not a show is renewed, pending, ended, or if a show was a miniseries. Active shows whether or not a show is actively in production and making new episodes, and it's a binary categorical variable. So a 0 corresponds with a false and a 1 corresponds with a true. So for example, at the time of this data set, Stranger Things had a 1 representing true under this variable, meaning that the show is still actively being developed. We know this to be true because the data set was created back when Stranger Things had only released its second season. Genre is the more basic label given to the show, such as comedy, drama, reality. The language variable just shows the original language that the show was created in. And then under numerical variables, we have the number of seasons and episodes, as well as the minimum and maximum length in minutes of all of the episodes.
So for data preparation and summary, we did some data cleaning because our data set needed it. And first, we limited the number of variables in our data set since there was some repetitive information. For example, in the original data set, there was a seasons column, a seasons parsed column, and an episodes parsed column. And the seasons and episodes parsed columns had the same information as the seasons columns, but they were separated to be more easily manipulated. So we were able to do away with the seasons column altogether. There was also some more repetitive information in the data set that needed some cleaning. The original data set had the columns genre label, genre, and table, and these three columns essentially had all the same information. So we decided to get rid of the genre label column altogether. And after doing that, we then renamed the genre column to Netflix labels, and we renamed the table column to genre. We also arranged the observations in alphabetical order by title, which made it easier for us to quickly find specific observations.
Our key numerical variables were seasons, episodes, and runtime. In our summary table of seasons, we found the first quartile to be 1. One season is expected. The median was 1, and the mean was 1.35. The third quartile was 2, with a max number of seasons being 8. The seasons variable computed the first quartile is 8, the median is 10, the mean is 15.29. The third quartile was 20, and the max number of episodes was 120. Our data had separated minimum and maximum runtimes, so we put them into separate summary measures. The runtimes are in minutes. The first quartile for the minimum 23 with a median of 26.50, a mean of 30.77. The third quartile is 42, and the max is 88. For the maximum runtime, the first quartile is 25 with a median of 37, a mean of 40.37. The third quartile is 54 minutes, and the maximum runtime is 152. There are no movies present in the data set, so we were surprised by the length.
We organized our categorical variables of status, language, and genre into frequency tables, and the data set shows that there are more shows pending than shows that have ended. And the most common language for shows is English with 305, and the second closest is Spanish with a far gap at only 16. The most common genre has been children's with 77 shows, and docuseries trailing close behind.
We wanted to do a two-way table for our categorical data organized by language and status variables, and then the genre compared with status variables. The data revealed that the frequency of English shows is much higher, with the second closest being Spanish. For a genre variable, the children's genre has the most frequency.
Next, we combined our numeric and categorical variables in order to visually represent certain correlations within our data. So this is our bar graph. For this graph, we looked at the relationship between the status of the show and what language the show is in. So for example, all the shows in Arabic have pending status. That's the leftmost on the graph. While all the shows in Turkish, the rightmost on the graph, have all been renewed for additional seasons. For shows in English, there's a mix between each of the ended, miniseries, pending, and renewed categories.
For our next graph, we did a histogram, and we looked at the relationship between the maximum length of episodes and their frequency in the data set. And as you can see, based off of the graph, the maximum length of an episode with the most frequency in the data set seemed to be around 25 minutes.
For our box plot, we evaluated the relationship between the number of seasons and show genre. The genres present in our data set include animation, anime, children, comedy, docuseries, drama, foreign language, Marvel, reality, and variety talk. The thick black lines represent the median, the boxes represent the first quadrant, and the dots throughout represent the minimum and maximum points. So for example, in the children's genre, which is the like orange one, the median length of seasons per show is 2 seasons, while the longest Netflix original TV show is 8 seasons long.
For the scatter plot, we looked at the relationship between the episode length and the number of episodes that a show has. As you can see from the scatter plot, there really is no kind of curve, and the dots are pretty much all over the place. This can lead us to believe that there's not any correlation between the two variables, showing that the episode length does not have an effect on the number of episodes the Netflix original TV show has.
So as you can see on the bubble plot, it shows the relationship between the number of episodes, number of seasons, and the status of the show. You can notice at the bottom near the left, the ended shows aren't really as visible because they're kind of occluded by the rest. And this kind of shows that most of the shows that either end after their first pilot episode or after the first season.
For our heat map, we wanted to show the relationship between 3 different variables: the genre of the show, the status of the show, and how many seasons a show has. As you can see in the map, many of the shows, regardless of the genre, have around 2 seasons for the renewed, pending, and ending status. And as for the mini-series status, all of the shows, regardless of the genre, all only had around 1 season.
Next, we will move into the regression portion of our project. Simple linear regression uses one predictor variable to output one response variable with a likely value. In the Netflix Originals dataset, we use the number of episodes as a predictor variable to the response variable, which was the number of seasons. These two values coincide, so we wanted to see the relationship. The usual form of simple linear is y equals mx plus b, which you might be familiar with. We use the predict function to find the answer. So if the show has 100 episodes, the number of seasons will likely be around 6.5. Or if it has 55 episodes, the seasons will be about 3.8. As you can see, residual standard error is used to predict the error, which here is 0.8469. This is relatively higher than expected, so it may not be the best model. However, our multiple R-squared value explains the variability as 54.24%, which is relatively low. And the adjusted R gives that 54.11% of the time we are making a valuable prediction. Here we see the line of regression, which is the slope, shown as the blue line across. There's a positive slope, and the dots are clearly lined up along the direct line of seasons because our data is pretty straightforward with whole numbers. Our data is relatively grouped with a few outliers on the higher portion of the graph.
So over here, you can see the logistic regression. This is primarily used to predict the results of a binary categorical variable, something like a win-loss or inactive-active status. This logistic predicts true or false values as well. So we decided to use the active variable in our Netflix dataset to predict true or false. We tested if the predictor show had 3 seasons, would it be active or inactive? And our model predicted active to be true. The data proved that the more seasons a show has, the more likely it is to remain active. And for every % increase in a season, the likelihood that the show will be active will increase by 84%.
Next is the classification aspect of our project. So for our k-nearest neighbor model, we made 3 key predictions by finding correlation between the language of a show and the number of episodes. First, we predicted what a show in English with 50 episodes would look like, and it turned out to be under the children's genre. A similar calculation was made for a show in Spanish with 25 episodes and a show in English with 10 episodes.
So for our k nearest neighbor model, R chose to use a 5 nearest neighbor model in order to get the highest accuracy for the predictions, which can be seen in the graph on the right as the 5 nearest neighbor model yields the highest accuracy. And based on this model, the genre with the most shows is docuseries followed by foreign language. Thank you for listening to our data science final project.
Thank you for a wonderful semester.
Thank you. Yeah, and life is beautiful.